excuse me, in the last video, I had the the ground on without any friction. So I want to show you what happens if there's no friction and there's an impulse. So the last video I had, I just put the impulse into here, and then you see this thing moving around. Well, it's if you have the impulse, it's just going to rock back and forth. So let me show you. This is completely frictionless, and so we're going to go and all we're doing is just spinning this thing around, wham, and we're just whacking this thing into the side there, right? So we're going to go real fast, and I promise you it's not going to go anywhere. Like maybe a freakish little, it hits this and kind of jumps out, but for the most part, this thing's going nowhere fast. Okay, so that's important because it's not supposed to. That's because there's no friction for this to play off of. So let's go back and now let's put some friction in here and go. Let's just put, say 0.5. Simple. And then we do the same thing, right? And let's speed it up. Speed it up. Right? But see now these little hops that it's getting, they're asymmetrical. So it's not going back exactly where it started. Some of them are inching a little bit, but you can see it's giving a little bit more to the right. So you're just kind of getting these little hops. And you can make it better. I mean, this is just an experiment, but you can see, with friction, we now have a system that's kind of jumping out of its position, whereas before without friction, see, we start over here, it ends over here. So without friction, it's going nowhere. With friction, you're going to get these tiny little hops because it's asymmetrical. This thing hits, it strikes, it jumps, it goes out of the way. I mean, it's not, So, and all I did was take this little rubber axle and sped it up as fast and as hard as it could go. Right? No, it's no big deal. And I put this little, um, uh, you know, flipper on it so it'll hit it and boom. So it's just going like that, and it's just spinning this way, and it's going to knock it into that thing. Um, and it's not magic, but you're getting the impulse. So you get this impulse, and if there's friction down here, it's not going to be able to settle exactly where it was at, just because there's friction. Now, if there's no friction, I mean, it's a completely different story, But I mean, if there's lots of friction, well, actually, what does it do with infinite friction? How do you get infinite friction? It's not doing a whole heck of a lot, is it? Well, it can't, really can't. Anyway, so you get the idea. But it's something to mess with, something to figure out. You can do the mechanics and figure out. Actually, let's go back because that's annoying. Do all the forces, show components, and then let's see what else. Velocities, momentums. I mean, this thing is kind of sweet. Right, you don't need all that in here, but I guess you could do momentum. And boom. There you go. Chaos. Yeah. So anyway, that's the Lewis drift. Again, this isn't a great application for it. I'm just showing you the mechanics of it. So why this thing works. It's using the friction to create an asymmetrical impulse. So without friction, you're going nowhere. With friction, you're not really going anywhere fast. Thanks.